I'm counting down the top 10 algebra mistakes everyone makes, and I bet you won't get them all right.
But this method is incorrect. But this answer is incorrect. But this answer is incorrect. But this answer is incorrect.
Whether you're just starting out or you think you've mastered algebra, the simplest slip-ups to a jaw-dropping conceptual error at number 1.
Kicking off our list at number 10.
Incorrect combining of terms. Let's look at an example. 3x plus 2y. How will you go about solving this? What some students do here is to add the 3 from the 3x term to the 2 from the 2y term to get the value 5. Then combine the variables x and y. And this method gives us an answer of 5xy. But this answer is incorrect. The reason students make this mistake is because they often apply the rules of simple arithmetic to algebra. Just as 3 plus 2 equals 5, they assume 3x plus 2y equals 5xy. But they forget that when variables and their exponents are involved, they determine what the term actually represents. So in algebra, the rule is that when it comes to the addition of terms, they can only be combined if they are like terms. That is, if the variables and their exponent parts match exactly. But if their parts are not exactly the same, they cannot be combined. They must be left alone. For example, if we had the expression as 3x plus 2x, this would give us the answer 5x because the variable x is the same for the term 3x and the term 2x. Note that this also applies when terms are being subtracted. So the right way to solve this example is to leave it the way it is. 3x plus 2y. Since 3x and 2y both have different variables, x and y, they cannot be combined when adding terms.
From what you can't combine, we move to what you can't cancel. At number 9,
canceling terms incorrectly in fractions that are added or subtracted. So let's take a look at an example. X plus 2, all divided by x. How will you go about solving this? What some students do here is to cancel the x in the denominator with the x in the numerator to give us 1. Then they simply drop the plus 2, thinking it can't be divided by the x. So this becomes 1 plus 2, which equals 3. But this answer is incorrect. Students make this mistake because they learn early on that when fractions have common factors, like 6x over 2x, you can cancel out the x to get 6 over 2, which divides to get 3. So when they see the expression x plus 2 all over x, they think they can also cancel the x because it appears in both numerator and the denominator. But this way of thinking is wrong. The numerator, x plus 2, is a sum that forms one grouped expression, not a product. Therefore, canceling does not apply here because the x in the denominator is not a factor of the expression x plus 2. So, to simplify this expression, you either factor the numerator, if there is a common factor, or split the fraction into separate terms that share the same denominator. Note that this rule also applies when terms are subtracting. So, let's first check if the numerator can be factored to see if there is a common factor with the denominator. Now we see that the expression x plus 2 cannot be factored. So there is no common factor with the denominator x. Now, since we cannot factor the numerator, let's split the fraction as x over x plus 2 over x. Notice that each term in the numerator now has the same denominator, x. So for the first fraction, the denominator x cancels out the numerator x to give us 1. Next, for the second fraction, since x and 2 have nothing in common, we cannot cancel them so they remain the same, 2 over x. Thus, our simplified expression becomes 1 plus 2 over x, our correct and final answer.
next.
a foundational mistake that happens even before you get to combining or canceling. Number 8.
Failing to distribute to each term. So let's take a look at an example. 4 times into parenthesis 2x plus 5. What some students do here is to multiply the number 4 only by the term 2x. And this method gives us the expression 8x plus 5. But this answer is incorrect. Students make this mistake because they assume that since the term 2x inside the parentheses is right beside the number 4 outside, they only need to multiply 4 times 2x. They then leave the plus 5 in the parentheses unchanged, forgetting that it also needs to be multiplied by the 4. But this way of thinking is wrong. When you have a number in front of a parenthesis, the number is supposed to multiply all the terms inside the parenthesis. So, the expression 4 times into parenthesis 2x plus 5 simply means the number 4 multiplies everything inside the parenthesis, that is the terms 2x and 5. So we calculate this, starting from our left side as 4 times 2x, which gives us 8x, plus 4 times 5, which gives us 20. Thus, this gives us the expression 8x plus 20, our final and correct answer.
Distribution is key, and it gets even trickier when you're multiplying binomials. Our number 7 mistake.
Not multiplying every term when expanding binomials. So let's take a look at an example. X plus 3 in parenthesis times into parenthesis x plus 2. How will you go about solving this? What some students do here is to multiply the x terms, x times x, to give us x squared, and then multiply the constant terms, 3 times 2, to give us 6. This method gives us the answer, x squared plus 6. But this answer is incorrect. Students make this mistake because they think that multiplying binomials is the same as multiplying a single term. As a result, they only focus on the first and last terms, assuming that's enough, and forget the cross products in the middle. But this way of thinking is wrong. The rule is such that when multiplying binomials, you multiply each term in the first parentheses by each term in the second. So to solve our expression, we multiply the x term in the first parentheses by the x term in the second to give us x squared. Plus, we multiply the same x term in the first by the constant term 2 in the second to give us 2x. Plus, we multiply the constant term 3 in the first by the x term in the second to give us 3x. Plus, we multiply the same constant term 3 in the first by the constant term 2 in the second to give us 6. So our expression becomes x squared plus 2x plus 3x plus 6. Now since we have the like terms 2x and 3x, we add them. So 2x plus 3x is 5x. Then we plug the 5x back into our expression as x squared plus 5x plus 6. Thus, our expression becomes x squared plus 5x plus 6, our correct and final answer.
This next mistake is a classic gotcha moment that many students fall for. At number 6.
Forgetting the middle term when expanding a binomial square. So let's take a look at an example. X plus 3 all square. How will you go about solving this? What some students do here is to square the x term to give us x squared, then square the constant term 3 to give us 9. So this gives us the answer, x squared plus 9. But this answer is incorrect. Students make this mistake because they know that when you have a single term all squared, the exponent affects the entire term. They then assume the same rule applies when you have two terms, like x plus 3, and so they square each part individually. But this way of thinking is wrong. When you have a binomial square, note that the different terms inside the parenthesis are considered as a single grouped expression. So the square applies to the entire group inside the parentheses as one unit, not to each term separately. Squaring a grouped expression follows a different process than simply squaring one term. So to expand the binomial square, the rule is that you square the first term. Plus, you multiply the first by the second term, then multiply the product by 2. Plus, you square the second term. Note that this rule also works when the binomial square has a minus sign. The only difference is that the middle term becomes negative from multiplying the positive first term by the negative second term. So to expand our binomial square, we square the x term to give us x squared. Plus, we multiply the first term x by the second term 3 to give us 3x. Then we multiply this product by 2 to give us 6x. Plus, we square the second term 3 to give us 9. So our expression becomes x squared plus 6x plus 9. Our correct and final answer.
Moving into the top 5, we're shifting our focus from simplifying to solving. At number 5,
not dividing or multiplying all terms on one side. So let's start with an example. 2x plus 4 equals to 10. What some students do here is to divide the 2x term by 2 to give us x. Then divide the constant term 10 by 2 to give us 5, while ignoring the constant term 4. This gives us the equation x plus 4 equals to 5. But this method is incorrect. And because of that, if we continue solving for x, we will end up with the wrong answer. Now, the reason students make this mistake is because they see the 2x term as the closest when solving the equation from left to right and immediately want to cancel the 2 out, forgetting that the plus 4 is part of the group 2x plus 4 on the left side. The rule for dividing all terms on one side is that if you divide one side of the equation by a number, you must divide everything on that side by the same number. Note that this same rule applies when you are multiplying one side of the equation by a number. You multiply all the terms by that same number. So the correct method to solve this equation is to divide every term on the left and right side by 2. So, starting from our left side, for the 2x term, 2 cancel out 2 and leaves out the x. Plus, for the constant term 4, 2 divides it to give us 2. Now, since all terms on our left side has been divided by the 2, we move on to divide everything on our right side by 2. So, for the constant term 10, 2 divides it to give us 5. So the equation now becomes x plus 2 equals to 5. Now we have applied the rule correctly. So when we solve for x in this equation, we end up with the solution x equals to 3. Our correct and final answer.
our next mistake, at number 4, is a more nuanced concept that's easy to get wrong. Number 4.
Mistaking coefficients and exponents. So let's take a look at an example. 3y to the power 3 times 2y to the power 4. How will you go about solving this? What some students do here is to multiply the coefficients 3 and 2 to give us 6, and then multiply the exponents 3 and 4 to give us 12. This method gives us the answer 6y to the power 12. But this answer is incorrect. Students make this mistake because they assume that since the coefficients and variables 3y and 2y are multiplying, then their exponents 3 and 4 must also be multiplying. But this way of thinking is wrong. The rules that apply to the coefficients and variables when multiplying does not apply to the exponents. When two variables with exponents are multiplying, the rules are such that for the coefficients, that is, the numbers in front, we multiply them as usual. Then for the variables with exponents, if the variables are the same, we keep the variable and add the exponents. So to solve our expression, 3y to the power 3 times 2y to the power 4, we multiply the coefficients 3 times 2 to give us 6. Then for the variables with exponents, since the variables are the same y, we keep the variable y and add the exponents 3 plus 4 to give us 7. Thus, our expression becomes 6y to the power 7. Our correct and final answer.
This next one is a simple but costly oversight that can flip your answer on its head. Number 3.
Failing to flip the inequality sign. So let's take a look at an example. Negative 2x is greater than or equal to 10. How will you go about solving this? What some students do here is to divide the negative 2x term by negative 2 to give us x. Then divide the constant term 10 by negative 2 to give us negative 5. So this gives us the answer x greater than or equal to negative 5. But this answer is incorrect. Students make this mistake because they carry over habits from solving equations, where dividing by a negative number does not affect the equal sign. They assume inequalities work the same way, so they keep the inequality sign even after dividing by a negative number. But this way of thinking is wrong. When solving inequalities, the rule is that if you divide both sides by a negative number, you must flip the inequality sign. So if the sign is greater than, we reverse it to become less than, and vice versa. Also, if the sign is greater than or equal to, we reverse it to become less than or equal to, and vice versa. Note that this also applies when multiplying a negative number on both sides of the inequality. The sign reverses. So to solve our inequality, we divide the terms on the left side and right side by negative 2. So starting from the left side, on the negative 2x term, the negative 2's cancel out to give us x. Then, moving on to the right side, on the constant term 10, the negative 2 divides it to give us negative 5. Now, since we divided both sides by negative 2, we flip the sign from greater than or equal to less than or equal to. So our inequality becomes x less than or equal to negative 5. Our correct and final answer.
This next mistake challenges a fundamental assumption many students have about a squared equation. Number 2.
Forgetting that a squared equation has both positive and negative solution. So let's take a look at an example. X squared equals 16. How will you go about solving this? What some students do here is to take the square root of the x squared to give us x, then take the square root of the 16 to give us 4. So the answer becomes x equals 4. But this answer is incorrect. Students make this mistake because they learn early on that square root of 16 is 4. So when they see the equation x squared equals 16, they immediately apply the square root symbol and only think of the principal root, the positive solution 4. Not realizing that solving a squared equation is different from evaluating a square root. Solving a squared equation means finding all values of the variable that make the equation true. So to do this, you take the square root of both sides to remove the square. Then, because it's a squared equation, you must include both the positive and negative roots in your answer, giving you 2 solutions. Note that this rule only applies to squared equations. For equations with higher exponents, you get 2 solutions if they are even, and 1 solution if they are odd. So, to solve our equation, we take the square root of the x squared to give us x. Next, we take the square root of 16, remembering to include both signs. This gives us positive 4 and negative 4. Thus, we get the equations x equals positive 4 and x equals negative 4. Our correct and final answer.
And now, the moment you've been waiting for. The number 1 most common algebra mistake is a real aha moment. The number 1 mistake:
failing to apply the zero product property correctly. So let's take a look at an example. X minus 2 all times into parentheses, x plus 3 equals to 6. How will you go about solving this? What some students do here is to equate the x minus 2 to 6 and then equate the x plus 3 to 6. So when they solve for x in both equations, This gives us the solutions, x equals 8 and x equals 3. But this answer is incorrect. Students make this mistake because they learn early on that product equations that equal to 0 can be solved by the zero product property. For example, with x minus 2, all times x plus 3 equals 0. They apply the zero product property to get the answer, x equals 2, and x equals negative 3. So when they see a similar looking equation like x minus 2, all times x plus 3 equals to 6, they mistakenly apply the same process and set each factor to 6. In doing so, they forget that the equation equals 6, not 0, so the zero product property does not apply. The rule for applying the zero product property is that the equation must be written in factored form, and the entire expression must equal 0. So, to solve our equation, let's first expand the expression on our left side. This gives us x squared plus x minus 6 equals 6. Next, let's group all terms on the left side. So we add negative 6 to both sides. And this becomes x squared plus x minus 12 equals 0. Now let's factor out this quadratic expression. So to factor out this expression, all we need to do is find two numbers that multiply to get the constant term. In this case, it's negative 12. Those same two numbers must also add up to give the same coefficient of the x term, which is 1. This takes some trial and error and depends mainly on how good your multiplication is. The two numbers here will be positive 4 and negative 3. Positive 4 times negative 3 equals negative 12. Positive 4 plus negative 3 equals positive 1. So after finding these numbers, all you do is put them in parentheses with the variable x, and you are done factoring your quadratic. So we have x plus 4 and x minus 3. Now, if there's any part up to this point that you don't fully understand, you can check out my videos for a more detailed explanation. So we have the expression x plus 4 times x minus 3 equals 0. Now here we can apply our zero product property rule, since we have our factored form on our left side, and the entire expression equates to 0 on our right side. So we'd equate x plus 4 to 0, and equate x minus 3 to 0. So when we solve for x in both equations, this becomes x equals to negative 4 and x equals to 3, our correct and final answer.
And there you in it, the top 10 algebra mistakes everyone makes. Do you agree with our list? And which mistake surprised you the most? Let me know in the comments below. Watch our other videos for more, and don't forget to get our full algebra course at ultimatealgebra.com.